Welcome to House of Past Paper Solutions. This is the 9709 Pure Mathematics October-November 2023, paper 3.3. Okay, if you need the variants 3.1 and 3.2, their links are in the description. And also, if you can't see the text, I'd recommend a quality that is at least 720 pixels. So 720p, I mean the P is for progressive, sorry. Okay. P. Now, question 1. Solve the equation ln x plus 5 is equal to 5 plus ln x. Give your answer to 3 decimal places. So this is a logarithmic question. Okay, so the first thing that I'll do is I'll subtract ln x both sides. Then I'll have ln x plus 5 minus ln x is equal to 5. And then I'm going to use this property, logarithmic property, which says that ln a minus ln b is equal to ln a over b. This is a property that you should know for logarithms. If you don't know the property, if you don't know logarithmic properties, you can comment in the description, and then I'll send a link for a video with that. Okay, and then now you combine those, and then you have ln x 5 over x is equal to 5, and then you take logarithm, you take the exponential e both sides. So you have e, put an e here, the e, then to the power of 5, like that. Okay, and then here, now when you say e to the power of ln, the ln goes away. Okay, so you're left with x plus 5 over x is equal to e to the 5. All right, and then now you want to simplify and make x substitute the formula, so multiply both sides by x, and then we have x plus 5 is equal to x multiplied by e to the 5. Take that x to the side, then we have x minus x e to the 5, e to the 5, like that, multiplying it is equal to 5. And then you can, this becomes negative 5. Then you can factor out the x, then you have 1 plus, you'll be left with 1 plus e to the 5 is equal to negative 5, like that. Okay, and then you can divide both sides by 1 plus e to the 5, and then therefore your final answer will be e is equal to negative 5 over 1 minus e to the 5. But remember, the question said to 3 decimal places, so you need to plug that in the calculator. And when you do that, you have your answer. Your answer to 3 significant figures is x is equal to 0.034. Okay, to 3 dp. 3 dp, sorry, not significant figures, but rather decimal places. All right, that's it for number 1. Then now we go to number 2. Find the quotient and the remainder when 2x to the 4 minus 27 is divided by x squared plus x plus 3. Okay, so what you want to do, you see, this is a quadratic equation, and it doesn't have the cubic terms. It doesn't have the x to the 3, right? It doesn't have x to the x squared. It doesn't have x. But you want to write them as placeholders, so that when you do your subtraction, because remember you're gonna do what I call the DMS method, where you divide, you multiply, then you subtract. Okay. So you write your 2x squared plus x plus 3. Okay, and then you want that, then you set up. So when you're setting up for the division, you want to have these 3 as the placeholders, so that when you do your subtractions, the x and their exponents will line up well. So for example, when you want to subtract x squared, you want to have an x squared on top. You don't want it not to line up. You don't want to have x cubed on top and then you want to subtract. That just makes your work difficult. Let me show you what I mean. So you want to say x 2x to the 4 plus 0 x cubed plus 0 x squared plus 0x plus the constant term, which is minus 27. Okay, like that. So okay, so now we'll divide the highest. We're using the highest power, yeah. So using the highest power, yeah, which is 2. So we're gonna use that to divide into 2x to the 4. So when we do that, we get 2x squared. Then we multiply that 2x squared by multiplied by everything. That's the multiplication step in the DMS method, right? And then when you do that, you have 2x squared multiplied by 2x, which will give you 2x to the 4 plus you see 2x multiplied by x, that will give you 2x cubed. You see, now you have the x cubed term. If you didn't have it, this would be, you would have written negative 27 right here, negative 27 right here. And now when you want to carry out your subtraction, it just makes your life harder. Right? But then if you put placeholders for the missing constant, for the missing terms of x, then it will make your life easier. Right? And then that's plus 6x squared. Okay, like that. And then we are going to do the subtraction. We subtract, when we do the subtraction, this is 0 here, and this is just negative 2x cubed. This is negative 6x squared, and then we drop down to 0 plus 0x. Then we do the DMS method, the DMS procedure once more. We divide again. Now we are dividing this bottom, the remainder, yeah. We're dividing it using the x squared term. So when we do that division again, we get negative 2x. Then we multiply the negative 2x again with this whole polynomial. All right. So when we do that multiplication, we're gonna get 2x cubed minus 2x squared minus 6x. Right. Then now we're in the subtraction stage. We want to subtract that, and then I'm gonna put bracket so that I can subtract properly. This becomes negative because this becomes 0. Negative 2x cubed minus minus, so that becomes plus 2x cubed. So these two just annihilate each other, and then it's just 0 here. And then here you have negative 4x squared plus 6x. Right. Then what you want to do next? You want to drop down the negative 27. Okay. And now you have negative 27 here. Then you carry out the DMS procedure once more. You divide again. When you do the division, you get negative 4. Then multiply negative 4 multiplied by 2x squared. X squared plus x plus 3. When you do the multiplication, you're going to have 4x squared minus 4x minus 12. And then you do the subtraction. Again, I'll put brackets here. When you do the subtraction, this 2 is equal to 0. 6x minus 4x is 10x. So you have 10x here. And then here you just have negative 27 minus 12 is equal to negative 15. Okay, and then when you've done that, you've completed your second number 2. So your quotient, which is the answer, quotient will be this right here, and your remainder will be this right there. Okay, so you have 2x squared minus 2x minus 4. If you want to know how to do this method in detail, you can comment in the comment section, and then I'll send you a link to a video. I'll even do a video where I explain it in detail in just under 3 minutes. Just need 3 minutes for you to understand this concept. Really, it's not that difficult. It's one of the easiest topics that you ever do here. All right, so those are your 2 answers, and that's it for number 2. Now, number 3, it says, on a sketch of an argon diagram, shade the region whose points represent the complex number z, satisfying the inequalities, this inequality here, and z is greater than or equal to modulus of z minus 4i. So the first thing that you want to do, especially for this one here, you want to rewrite it in this form here, which is z minus a, right? Z minus a modulus greater than or equal to the radius. Okay, so this is going to be a secular loci. All right, so that's the first thing that you want to do. So when you rewrite that, it becomes z, then minus, so you're factoring out a minus, then this becomes 3, factoring out a minus from the z minus 3 minus I. When you do that factoring out, this becomes plus, so that if you multiply the negative in, it returns to the original function that we had. Okay, so this becomes plus I bracket, then modulus. Okay, it's less than equal to 3. You see, where a is this value. This is where your a would be. See, this is the same. That would be the same right there. So when you do that, now you're ready to draw your loci. Okay, your Argand diagram and your loci. All right, so let's draw the x's. Okay. Okay, so when you've drawn your two loci representations, they'll look like this. Okay, so I can explain this. So what you have is you have the circle. This is the formula for the circle. This one right here, and this is essentially just the circle, the center. So 3 plus I, this is 3 and this is 1. So you go 3 in the real axis and then 1 up in the imaginary axis. Then you will locate your center and then you draw with your compass. It's probably best to bring a compass in the exam. And then you open your compass to a radius of 3. It could just be 3 centimeters. And then you draw your circle. You draw your circle using your compass. And then you locate 2I. All right. You want to locate 2I on the imaginary z, and then you draw a straight line with a gradient of 0. The question is, why am I going to 2I? Because look, if you, for example, right here, this, you have to rewrite it as z plus 0 plus z minus 0 minus 0I, that is greater or equal to z minus 0 plus 4I. All right. And then what you want to do is to draw the perpendicular bisector between these two loci points. So if you go to the point 0, 0, it would be the center of these two axes. And then if you go to point 0, 4I, that would be about somewhere there. Okay, let's say 4I should be in the bisector, the perpendicular bisector for this line here. It's going to be in the middle. The middle of 4I is 2. It's 4I divided by 2, right? So it's 2I. That's how you locate 2I. Then you draw that red line right there. Okay. So now it's saying, what this is essentially saying is that any points, so the distance from 0 to z to the point z that you locate has to be greater than the distance from this z here to with the center or point 0 plus 4I. Okay, so whatever point that you pick, right? So for example, let me show you an example. So let's say, so these are the 2 points of reference, right? 0, 0 and 0, 4I. Those are the 2 points of reference. Okay, so for example, if I pick point, let's say I want this here, point here in the diagram, I'll pick this point. The distance, the point is to be right. Okay, so the distance from point 0, 0, that one, it has to be greater than the distance from point 0, 4I. Okay, and as you can see that would happen if all the points are in this section here, all the points are above the line, then you can be certain that that distance is always going to be greater. right? It is always going to be greater no matter where the point is, as long as the point is above the red line. So that is what this equation is essentially talking about. So you're saying that the locus of points where this would happen is above this red line, right? But then that's one condition. Remember, it says sketch the on a sketch of an Argand diagram, shade the region whose points represent the complex number satisfying both inequalities, right? So for the second inequality, it is saying that if you pick a point z, right, with the center being 3 plus I, and with the radius of 3, right? Any point that you pick has to be less than, so it has to be inside the circle. It has to be less than this inequality here. So it has to be inside the circle. So the second condition now is that the second point that you pick has to be inside the circle, right? And you can see that the only section here which satisfies both inequalities is this part here. So you can see it is this part. So if you pick any point in this section, it will satisfy this first inequality, and then it also satisfies this one because it is inside the circle. And let's say it is let's say the point that you pick is this one right here, is this one. The distance from 0 0 will always be greater than the distance from 0 4 to 4i. All right, so that's the logic behind this. Okay, so final answer, you should leave the final answer like this. You should leave the final answer like that. Okay, and then you just shade that part that is shaded in red. This part here, you have to shade it, and then you get your 4 marks. So you're getting 1 mark for shading, you're getting 1 mark for the circle, you're getting 1 mark for the line, and then you're also getting 1 mark for the center of the circle. So that should be 4 marks. All right. Okay. So that's it for question 3. Then question 4 says the parametric equations of the curve are x is equal to x is equal to cos over 2 minus sine theta. And then you have y is equal to theta plus 2 cos theta. So that dy dx is equal to that. All right. So you're going to have to use the chain rule because we have the common variable theta here. So we'll use the chain rule to find, then we'll find dx d theta and dy d theta. So we'll use the chain rule to find dy d. All right. So dx d theta would be, if you differentiate theta, you just get 1. Right. Actually, sorry, I was differentiating dy. So dx d theta is equal to. So what you want to do here, you have to use the product rule. In this case, it is the quotient rule, which has the formula v du minus u dv is equal to v squared. I'm sure you should know this by now. So when you do that, you're saying u over v. Okay, so this is v, this is u. So the v, if you take the v, and you have your 2 minus sine theta multiplied by the derivative of the u, or the derivative of cos theta in this case, which is negative sine theta, right? Then you're subtracting minus u, you're taking u, which is cos theta, and then you're multiplying it by the derivative of the denominator, which is v in this case, and then that will give you negative cos theta, and then all of that, you're dividing all of that by v squared, which is the denominator squared, sine theta squared. Right, then when you simplify, you will have dx d theta is equal to negative 2 sine theta. You're simply just multiplying in that bracket right there, and then plus sine squared theta plus cos, there's a bracket there, cos squared theta. Okay, to sine theta. Yes, plus sine theta. And then you have your cos theta right there. And then all of that is over 2 minus sine theta squared. Okay. All right. And then sine squared plus cos theta plus cos squared. Remember, this is an identity which is equal to 1. This sine squared plus cos squared is identical to 1. I'm sure you know this identity. It's in the data booklet, the MF19 data booklet. All right, so this becomes dx d theta is equal to 1 minus 2 sine theta all over 2 minus sine theta squared. Okay, then we'll leave it like that for now. Now we'll differentiate y. Now we want to go dy d theta. Okay, then when we differentiate those two, we just have 1 minus, because you differentiate theta, it just gives us 1. Differentiate 2 cos theta, it will give us negative 2 sine theta. All right. Then we'll use the chain rule, which says that dy dx is equals to dy d theta in this case, divided by dx d theta in this case, or you could say dy d theta multiplied by dx d theta. So that, d theta over dx, so that these two can cancel out. All right. So we'll now use the chain rule to do that. So in this case, I'm just going to divide. Okay. So we have dy dx is equal to dy d theta divided by dx d theta is 1 minus 2 sine theta over 2 minus sine theta bracket squared, like that. Then these two will cancel out. Then you reciprocate the denominator. Or the denominator of a denominator is the numerator, right? So now you have your final answer is dy dx is equal to 2 minus sine theta squared. And I'm sure that it was a show that question. See? And we have shown that. Okay. That's it for the question number 4. Question 5. The diagram shows part of the curve y is equal to x squared cos 3x for this domain in this maximum point M where x is equals to a. Show that a satisfies the equation. Alright. So we know that at a, that is where the maximum is. That is the x value for M. So basically M is equal to x, a, and then some value of y, which we don't know. Alright. Okay, so we also know that the gradient at M here for the maximum point is equal to 0. So we know that at M, dy dx is equal to 0. So this is the fact that we use to calculate that. Okay. All right. So we want to find, so we have our y is equal to x squared cos 3x, right? So to differentiate these two, I'm gonna use the product rule. Okay, the product rule, which is v du plus u dv. That's the product rule for differentiating these two. All right. So, but essentially what you're doing here, as you can see, so you're selecting one term as u. So let's say this is u multiplied by v. Okay. So you're holding v constant, then differentiating u, then you add multiplying by v constant with v differentiated. That's what you're doing essentially. So dy dx would be equal to x squared. You want to, we are differentiating x squared and then holding cos 3x constant. So that will give us x2 multiplied by the constant cos 3x. Then we multiply by, we add more the derivative of cos 3x in this case, which is 3, which is minus 3 sine x, minus 3 sine 3 is 3x, multiplied by the constant x squared. When we do that, we have x squared multiplied by negative 3 sine 3x. All right. And then we simplify that, it becomes 2x cos 3x minus 3x squared sine 3x. All right. And then we know that, so this is dy dx. We know that it is equal to 0 if x is equal to a. All right. So we'll substitute. We have x to a cos 3x minus, this is a minus 3a squared sine 3a, right, is equal to 0, right? And this is equivalent of just taking that to the other side. When I do that, this just becomes positive. I mean, this just becomes equal to the positive, right? And then we look at the solution that way. So we have tan. So we somehow should form tan by dividing by x. Okay. So now, once we have those two, we can divide by cos 3a. And then we're also going to divide by a so that this a cancels out. It's the common term on both sides, right? Then once we have tan by itself, so we also divide by 3 as well. Okay. So when we do that division, we have tan 3a is equal to 2 over 3a, like that. Okay. And then now you can take the inverse of tan. When you take the inverse of tan, you have 3a is equal to tan inverse of 2 over 3a. And then you divide by 3 both sides. Then you have your final answer is a is equal to a third of the tan inverse 2 over 3a. And you would have shown. Okay. Like that. See? Give your answer like that. Okay. Part B. Use an iterative formula based on the equation in A to determine the value of A correlated to two decimal places. Okay, well now we want to take our formula. A is equal to 1/3 tan inverse of 2 over 3a. And then we want to convert it to a n plus 1 is equal to 1/3 tan inverse. This is the formula that we should form whenever we want to do numerical solutions. Okay. All right. Then if you look at the graph, this is the 6th pi. So probably about halfway somewhere here is about the 3rd pi. So I would use that as a reference value so that I can iterate the formula until I get to a. So I'll use the 3rd pi is when n is equal to 0. So for example, the initial value when a is equal to 1, I would say it's equal to 3 pi, of which 4 decimal places would be 1.0472. All right. So now what you want to do, you want to use the iterative formula to you want to plug in that value and then you use your calculator. you can replace a to the n, a subscript n, this one, those values in your calculator. So you punch this, you punch a third tan inverse of 2 over 3, 8 to the n in the calculator. You can replace the a to the n with the variable x, and then you just place equals. You plug in the value for a, in this case it should be 1.0472. You press equals, then you continue repeating that pattern to find a2, a3, a4, a5, a6, a7 until you get at least perhaps one. You can stop when there's an oscillation or when the last two digits are the same. All right, so we'll carry out that iteration. These are the values that you get. Okay, so as you can see here there's an oscillation. This is an oscillation right there. So when you get an oscillation, it's just going to keep repeating. All right, so you don't need to continue going. So when you've done that, now the question, remember the question said find the value of a correct to two decimal places. Okay, so to two decimal places, we just truncate it up to the, and truncate it up to the. So therefore, our answer, then we round it off. A is equal to 0.36. Okay, and that's only the sort of value of a would be. All right, like that. And then that's it for question 5. Question 6. Express 3 cos x plus 2 cos bracket x minus 60 in the form r cos x minus alpha, where r greater than 0 and alpha is in the domain from 0 to 90. Take the value of r and give a alpha correct to two decimal places. So what you want to do in this case, you want to expand and then compare coefficient. You want to expand what r cos theta is. Right. So first of all, the thing is, in this case, because you have a double angle here, two angle here, you want to first combine it so that you have one angle in this case, and then you expand r cos x minus alpha, and then you do a comparison of coefficients. Okay, so we first expand this, expand that, and then add it to the 3 cos x, then we expand that, right? And then we compare coefficients. All right, so I'll go ahead and do that now. So we have 3 cos x plus, in this case we have 3 cos x plus 2 cos x minus 60. Okay, so we have 3 cos x. We do the expansion using the double angle formula right here. When you have two angles, the formulas are found in the MF, in the MF19, the double booklet. So what you have, you would have cos 2 cos x. You're expanding that, right? Using the double angle formula for double angle formula for cos x. Cos, all right. So it will be cos x with cos 60 plus sine x sine 60. All right. And then sine 60 would be root 3 over 2. And then cos 60 will give you half. Okay, and you plug those in. So you have cos x plus, this is a plus here. There should be a plus there. Plus 2 cos x multiplied by 2 multiplied by that half. Right, this half here, which is just 1. So you have cos x here, then plus cos x plus 2 multiplied by the root 3 over 2. Then these 2 cancel out. So you have plus root 3 sine x. Okay, then you combine these two here, 4 cos x plus root 3 sine x. Okay, now we've expanded that. Now we're going to go in and expand r cos theta. R cos x minus alpha. Okay, when we do that expansion, we will take our r outside since it's constant again. Then we do the same procedure here, cos alpha plus sine x sine alpha. Then we have r cos x, right? In this case, also you can say, we can rewrite it as r cos alpha. You'll see why in a moment. Multiply by cos x, and then plus r sine alpha, multiply by sine x. Okay, that's the expansion. Now we can do a comparison of coefficients. Okay, so if we rewrite this part, sorry, if we rewrite that part, when we take it here, we have 4 multiplied by cos x plus root 3 multiplied by sine x. See, that's the comparison of the coefficients. So from this, we know that, therefore we know that r cos alpha is equal to 4, and also r sine alpha is equal to 3. Okay, then using these two, we could even form a triangle. Okay, so this becomes cos alpha is equal to 4 over r. Then that becomes sine alpha is equal to root 3 over r. You can draw a small triangle so that you can picture what's going on. All right, so now our triangle, the r, as we know that the r, using the soccer tool, the r is the hypotenuse. So we have r here, then we have cos, this the 4 will be the adjacent, and the opposite will be the root 3. All right, so we can even use the trig identity, the Pythagoras theorem to find r. So in this case, r would be equal to root 3 squared plus 4 squared, and then root all of that. When we do that, we're going to get r is equal to root 19 if you plug that in the calculator, right? And then we know that our alpha is incorrect here. Okay, we could divide that so that we get tan alpha. So we get tan alpha. So we have simply divided r sine alpha over cos alpha. When we do that, we have tan alpha is root 3 over 4. Therefore, alpha will be equal to tan inverse of root 3 over 4. And then we have 2 decimal places. Our alpha will be equal to 23.41, right, to 2 dp, because that's what the question asked. So we have our answers is r is equal to root 19, and we have our alpha is 23.41 degrees. Okay, and those will be our answers for question 6a. All right, question 6b then says, hence, every time you hear you see this hence here in any question, that means that you're somehow using this previous question solution to find you're taking it and then you're using it to solve the second part. In this case, you're taking the first solution, some part of the first solution, and then you're going to use that fact to solve the second part. So then it says, hence, solve the equation. This equation is equals to 2.5. As you can see, to make it easy, we're going to use that r, cos x minus alpha in this case. All right. So if we compare that, we can see that the difference now is just that the theta has been replaced by 2 theta, yeah, by 2 theta, but the negative 60 is still the same, negative 60. So the x has been replaced by negative 2x. Okay, so in this case they just said let x be equal to 2 theta. That's what happened in this case. All right. But you know what I'm gonna do? I'm gonna work it out. I'm gonna work out, find the value of x, and then use this substitution to find the value for theta. Okay. So we use r cos. So we use r cos x minus alpha. In this case, we're substituting the r in the alpha, which you just found. So we have root 19 cos x minus 23.41. All right, is equal to 2.5. Right. So I'll find the value for x and then use this substitution here. I'll use that substitution which says let 2 theta be equal to x. In this case, I'll use that substitution after I found the value of theta. Okay, so I will now have cos x minus 23.41. We divided by the root 19, so I have 2.5 over root 19. All right, and then when you find the principal value, in this case, you have x minus 23.41 is equal to cos inverse of 2.5 over root 19. Right, and then that will give me, when you plug that in the calculator, you will get x minus, this remains the same, 23.41 is equal to the principal value that I will get will be 55 degrees, 55.0 degrees to 1 dp. And then if I use the case diagram, you should know this diagram. If you don't understand it, then I'll put a link in the description in the corner right there, and then you can watch a video explaining the case diagram. Okay, so this is the principal value, 55 degrees that we found. So we want another, since cos is positive in this case, we want another value. We cos is also positive. In this case, it is this part. So we have this part is the 305, which is just 360 minus 55, 305 degrees. Okay, for cos. All right, so those are the principal values that we have. So we have that and 305. Right, then we can add 23 to both sides. So x would be equal to 55.0 plus 23.41 and 305 plus 23.41. Then you would have x is equal to you'd have x is equal to 78.41 and 328.41. Right, but we know that x is only equal to 2 theta. So now we can substitute what x for x. So now we can have 2 theta is equal to 78.41 and 328.41. We divide all of that by 2. Then we have theta is equal to 39.2 degrees. And we have 164.2 degrees. And then when we're at this stage, we want to check whether our values are in the given domain. All right, so the given domain is that theta has to be between 0 and 180. And if we check our values, both of them are within range. So both of them are acceptable. Therefore, those are our solutions. Okay. Therefore, both of them are our solutions for theta. All right. If you still don't quite understand how to do trig, you can comment in the comment section. Please, house, can you do a tutorial on trigonometry? I'll be glad to do that for you. And then question 7. Use the substitution u is equals to cos x to show that. Right. So every time you're using a substitution, the first thing that you want to do is to find the factor of changing the domain, because you're moving from the x domain to the u domain. So you want to find what factor by what factor, and find that factor you want to differentiate. If u is equal to cos x, then you want to differentiate. When you differentiate that, you have du is equal to negative sine x dx. Okay, thus dx in this case is negative 1 over sine x du. All right. And then the second thing, limits. So you want upper limit. You want to change the upper limit. So the upper limit is when x is equal to pi, right? So you have u is equal to cos pi. When you plug that in the calculator, pi is what? Pi. I'm losing it. A cos graph looks like this. This is 0. This is half pi, right? And that's pi. So it should be negative 1. Okay. That's where pi is for the cos graph. It should be negative 1. Okay. And then for the lower limit, you have u is equal to cos is 0. In this case, it's just 1. It's 0, right? Using that cos graph, it's just right there. Okay. And then what you want to do next, now you want to do the substitution inside the integral sign. So here you have negative 1 is the upper limit and 1 is the lower limit. And then sine 2x, you have sine 2x, sine 2x right there. And then you also have e, right, the 2 cos x, right, dx. All right, so we know that cos x is equal to u, right? Then we know that dx is equal to multiplied by negative 1 over sine x, right? And then what we want to do is we want to convert sine 2x using the double angle formula for sine 2x. That's what we want to do now. So it becomes sine 2x is equal to 2 sine x cos x, like that, right? So when we do that substitution, we'll now have our integral negative 1 1 minus 1 over this sine here. This is du right there. 1 over sine x multiplied by the 2 sine x. We are replacing sine 2x, 2 sine x, and then cos x. We already know that this is equal to u multiplied by u, right? Then we have e, the 2u, u, right? So these two cancel out. So now we have the integral from negative 1 to 1 of negative 2u e to the 2u. So this is 2u supposed to be here. Okay. E to the 2u du. All right. But it's not quite the same now, is it? So since we have this negative, to get rid of this negative, we can multiply it into the limits. That's flipping the limits. So we flip the limits. So the lower limit becomes the upper, and the upper limit becomes the lower limit. Right? It's just like that. We're just multiplying negative more in the limits, or simply flipping them. And then now you have 2u e to the 2u du, like that, and you've shown. If I go back, see, we've shown that integral from pi to 0 is equal to that same integral from negative 1 to 1 of 2u e to the 2u du, as you can see. So the first step that you want to do, where people get lost here, is doing that the factor thing that I told you about, because you're moving from the x domain, because you remember you have your input is x, then you are moving that input to a different domain of u. So you want to find by what factor, because remember it's supposed to be proportional. You want to find that factor, right? And that factor is this. That's the factor of conversion. All right. So that's why it means many people lose it, so they get it wrong. Because if you forget that, then you're going to be lost when you get to this part here, because now you want to know how to get rid of the sign x. All right. Okay. Then it says hence. Again, when it says hence, that means you're using the solution in the previous part. All right. So in this case, the easier one to integrate would be the integral that we just formed, which is from one integral of 1 to 1 of 2u e to the u 2u du. Okay, that's what we want to do for this part. All right, so I'm gonna show you two methods. I'm gonna show you the first method, process noting swap. You're going to use by parts in this case. So first method is by parts. Both of them is by parts, but this one is the in-class method. That's what I'll call it. This is the one that teachers teach you, which is messy. Actually, really, it's not that effective. You see why in a moment. I never use this anymore. So once I learned the second method that I'll show you, I have never used this method when I do my integration by paths. Okay, so you want to select a UV. All right, so you have your U. In this case, to denote a different U, I use U naught. U naught is equal to so you want to be able to use the formula UV minus integral of V naught du naught. Okay, so this is the formula that you use for by parts. So the U naught now is equal to 2U, and you use late so that you choose when you want to assume which value assumes U and which value assumes du, because this is essentially just U multiplied by, it's essentially U naught multiplied by dv naught. Okay, that's how you're treating these functions. And then you use late to assign those values. So the order of precedence is backwards. Okay, so L is for logarithmic functions, A is for algebraic functions, T is for trig functions, E is for exponential functions. So in this case, we have an algebraic function and an exponential function. And the one of higher precedence in this case for assuming the value of u is, as you can see, is the algebraic function, right? So the algebraic function will assume the value of u because it's of higher precedence. All right. Okay, so you have here u naught is equal to 2u. Then you have dv naught is equal to integral of e to u du, right? Then you want v naught is just going to be equal to, you differentiate the power, this is 2, then you divide by the solution, which is, then the function remains the same. Then you add du naught, it just becomes equal to 2, right? Okay, then now what you want to do, you want to do your cross multiplication. So your uv u naught v naught is that multiply, you're using the formula now, so you end up with u naught e to u minus the integral of v naught du naught in this case, which is e to u du. Okay, and then you plug in the limits. When you integrate that part, you have u naught e to u minus half e to u. Then you plug in the limits of 1 and -1. When you do plug in those limits, you will now have 1 e2, plugging in the limits. Then you have half e to the 2 multiplied by 1, and then you bracket minus, because this is the upper limit. Now I'm subtracting the lower limit, 1 minus 1, which is the lower limit. In this case, e to minus 1, bracket minus half e bracket 2 bracket -1 bracket. Okay, when you do that, you have e2 minus half e2 minus -2 minus half e to the -2 bracket. Then you can simplify these. When you simplify those two, you're just going to have, see, these are common terms, so you just have half e squared plus 3 over 2 e in the bottom, in the denominator now, since it's e to the negative 2. So you have 2 e to the 2, like that. Okay, then you can even factor out the half. I'm sure Cambridge would just accept it anyways. E to the 2 plus 3 over e2, like that. Okay, so this is the by parts that you're taught in class, right? Now, I want to show you a different one. Okay, a second method. This one is called the DI method. It's the second method, the DI method. But don't use it if you don't watch the videos, because there's a catch to it. You need to know a couple of things so that you can use it effectively every time. Otherwise, you're probably gonna make mistakes and you'd wish that you'd use that tedious method. All right, so let's integral from 1 to negative 1 of 2u e 2u du, right? Okay, so it's a similar concept. You want to make two columns here, di right there, and then you want to choose which function you're going to integrate, which function you're going to differentiate. So the D is for differentiation, the E is for integration. So in here, you can still use the same late for choosing the precedence for which value, for which function you're going to differentiate and which function you're going to integrate. But in this case, you can just look at the function and you see which one will reduce, in this case, to 0 if you differentiate it. See, that's why I said I'm just showing you this method so that you get motivation, so that you see that it's less tedious. Because if you had 2u 2u squared here, right, you would have to differentiate twice. You'd have to do by parts twice. If it was 2u to the cubic, you would have to do by parts 3 times. So you would have a by part inside of a by parts inside of by parts. And that becomes tedious. That's where the DI method comes in handy. All right, so in this case, and then so you do first you do 2 columns, a differentiation column and then the integration columns. Then you do rows. For the rows, you want to add and subtract alternatingly. Like that. Okay, so in this case, the one that's easier to differentiate and reduces to 0 is 2u. And then the one that's easiest to integrate is 2u. So when I integrate that, I'll get half e2u. Okay, and then I'll get a quarter e2u. I differentiate that, I'll get 2. Differentiate that, I'll get 0. So that's where I'll stop. Okay, since I can't differentiate it no more. Then you want to cross multiply like that. Multiply there, multiply there. And then you would have multiplied the 0 by whatever value would come here. But 0 multiplied by anything is just going to be 0 anyways. When you do the multiplication, then you have your u e to the u. Put the u squared. And then actually let me show you. Let me show you doing the multiplication so that you don't get lost. So you're multiplying 2u multiplied by half e to the 2u, right? Then you're adding that to minus. Now it's this minus here, right? Multiplied by 2 multiplied by a quarter e to the 2u. So it becomes negative 2 multiplied by a quarter e to the 2u. When you simplify that, you have ue the 2u minus half e the 2u. You plug in your limits. Right. When you plug in your limits, you will have e squared minus half e squared, and then minus bracket negative e to the negative 2 minus half bracket e to negative 2, right? Okay. And then you simplify those two. These are common. These are all common. So you simplify this bracket. When you simplify this bracket, you get half e to the 2. When you simplify this bracket, you get minus. It's going to be a plus in this case because it's minus minus. These two will give you minus. All right. Minus 3 over 2. In this case, e to the 2. Oh, in this case, it's actually, first you may write it like that first. Then you combine those two. Then you have your final answer as half bracket e squared plus 3 over 2 squared. Okay. So this one is much cleaner. See? It's much cleaner because you do your differentiation, all of your differentiation at once, all of your integration at once. Then you no longer need to use that formula v du again. No, you won't have to use it again because every time you always differentiate again depending on the polynomial that you have. So if you have eu to the 3, you will do by parts 3 times, right? If you have 2u to the maybe 6, then you do by parts 6 times. See, it's going to become tedious because now you have v minus integral of v du, right? Then when you carry out that part, you're going to have another v1 again minus the integral of v2 du2 again. Then you go again inside that this integral is by parts. Then you get another integral again, and then inside that integral is by parts again. So it becomes very tedious and you are most likely to make mistakes. But when you use the DI method, it's very clean because you carry out all your differentiation and all your integration at once. And then that would be it. Okay. All right. So that's it for question 7. Now we move on to question 8. My favorite, the differential equation. So it says the variables x and y satisfy the differential equation. The dy dx is equals to y squared or plus 4 over x bracket y plus 4 for x is greater than 0. It is given that x is equals to 4 when y is equal to 2 root 3. Solve the dE to obtain the value of x when y is equal to 2. All right, so the first step always is to do a separation of variables. Always, whenever you're attempting differential equations, you want to do a separation of variables. So in this case, what that means is you're taking the x's to the other side, to one side, and the y's to one side. Essentially, that's what separation of variables means. All right, so we'll carry on. All right, so when we do the separation of variables, we have dy. So we have dy dx is equal to y squared plus 4. I'm just copying the equation here. The dE first. So in this case, because we don't want the dy and the dx to be in the denominator. So we'll transfer dx to the other side, then we'll transfer the y's to the left hand side. Okay, so we have, when you transfer the y's, we have y plus 4 over y squared plus 4 dy is equal to 1 over x dx. Okay, then we want to carry out the integration here. All right, so first thing first, to integrate. So now once we've done the separation of variables, we can now start to integrate. So before I integrate, I want to do a separation of variables here. I want to separate this this fraction here. So I'll separate it like this. Y over the denominator 4 plus 4 over y squared plus 4 dy is equal to the integral of 1 over x dx. Okay. So now we can carry out the integration. Okay. When I integrate this first part here, the y over y squared plus 4, if I differentiate that, this is the integration of this type function, of the type function where the derivative is the numerator of the function. Okay, so if I differentiate f of x, I'll see that the solution is the numerator. So in this case, if I differentiate 2y squared plus 4, I'll get 2y, right? But here there's no 2. Therefore, to compensate for that not having a 2, I'll put a half sign outside. All right. So it becomes half. So it becomes half ln ln of the original. y squared plus 4. Okay, to see if that works, see if I differentiate that, I have half outside, then I'll multiply by, if I differentiate, then I'll multiply that by the derivative of y squared plus 4, which is just a 2y over the original, which is y squared plus 4. See, then that half goes away. That's why we need to compensate with the half outside, so that we get the original function, which is just y over 2y squared plus 4. Okay, just wanted to show you why that works. All right, so, and then now this part here is integration of the type function 1 over x squared plus ax squared. It's equal to 1 over a tan inverse of a of x over a, x over a multiplied by the derivative of x dx of the function x in this case. Right, okay. This is it's the integration of this type function. This is in the MF19 data booklet, right? But it's no use if you don't know how to use it, because you probably won't see it. You won't see that that's what you have to do in the exam if you haven't been practicing. So it's probably best you practice, and then you can recognize without having to go to the data booklet. All right. Okay. All right. So now ignore the parts that are in green. Okay, they don't really matter. The parts that are in green don't really matter. So just an illustration. Okay. What you want to concentrate on is the parts that are in blue. All right. So now to do that integration, I'll take the 4 outside. So plus 4, right? Then I'll put bracket 1 over you could rewrite this as y. Rewrite this as y bracket squared. Then you rewrite the 4 as 2 squared, so that you see so that it's in the form x squared plus a squared, like that. Right. So now you can clearly see that your a is 2 and your x in this case is y. Okay, I'm referring from the formula. This is from the formula that is found in the MF19 data booklet. Okay. All right. You can ignore the part in green again. So now this would become, I'll take the 4 outside, then multiply by 1 over a. The a is 2, multiply by tan inverse of x over a. The x is y over 2, right? Multiply by the derivative of the x, in this case the derivative of y with respect to y. So it's just going to be 1. So we can ignore that as well, since it's just going to be equal to 1. Why does it work? Because if we had, let's say x, let's say we had y squared bracket squared. So let's say the original was y to the 4, right? You could still reduce it in that form. Okay. All right. So now these 2 cancel out, and then that you're left with 2 here. So this whole thing here just becomes plus 2. And then you move that in. Tan inverse of x over 2. I mean y over 2, sorry. Okay. Is equal to the derivative of the integral of 1 over x is just ln x, right? In x plus c. Don't forget the constant of integration in this case. Then you want to use the initial condition to find c. The initial condition in this case, it says that when x is equal to 4, y is equal to 2 root 3. So we'll use that initial condition, which says that 4 to 2 root 3. Find what the value of sine of to find the value of c. So we'll plug that in. And when we plug it in, we have half ln we have half ln 2 root 3 squared plus 4, right, plus 2 tan inverse of 2 root 3 over 2 bracket is equal to ln 4 plus c, right? this just becomes half ln 16 inside plus 2 tan inverse of root 3, right, which is equal to ln 4 plus c. And then using the logarithmic identity, which says that a ln x is equal to ln x to the a. So we have 16 to the power of half, which is equivalent to root 16, which gives us 4. Okay, so we now have a lot of space. Okay, I thought I was running out of space, so I'll skip one line. We'll now have ln 4 plus 2 tan inverse of root 3 is equal to ln 4 plus c. Then these two can cancel out. Therefore, we have c as 2 tan inverse of root 3, which I'm sure you can plug that in the calculator. And when you do, it should give you 2 over 3 pi. Yeah, which is equal to 2 over 3 pi. But I just don't want to write 2 over 3 pi. I want to keep it as 2 tan inverse of root 3. You can choose however you would want to carry forward. So now the equation that we have is so the equation that we have now is equal to half ln y squared plus 4 plus 2 tan inverse of y over 2 is equal to ln x plus 2 tan inverse of root 3. Okay, so that's the equation that we have. All right, so now we can find, remember the question said, solve the differential equation, then obtain the value of x when y is equal to 2. So now we'll move on to that stage. Okay, so we have, using that equation, we have so we want x is equal to when y is equal to 2, right? So now we can substitute for those values for y, for the value of y. It's 2. Then when we substitute for y squared, 2 squared is equal to 4 plus 4, that's 8, plus 2 tan inverse of 2 over 2, which is just 1, right? It's equal to ln x, which we don't have, and we need to find 2 root, in this case, 2 tan inverse of root 3 is equal to 2 over 3 pi. Then I'll write it as 2 over 3 pi now. 2 over 3 pi, since we now need to find the value of x. Okay, so we can simplify that. We have 2, we can use that logarithmic identity, I mean the logarithmic law, and then we'll change that as to ln root 8, and then we'll leave it like that. Okay? And then tan inverse of 1 is equal to half, so this is just half pi, it's equal to half pi, so half pi, which is equal to ln x plus 2 root 3 1. So now we can take the ln to the other side and then take the half to the side. So we have ln root 8 minus ln x is equal to 2 over 3 pi minus half pi. Then the right hand side we have negative. Here we can use the logarithmic property once more, which says that ln a minus ln b is equal to ln a over b. Okay, so we have ln root 8 over x is equal to negative 6 pi. Then we can take e to both sides. Then we have root 8 over x is equal to e to the negative 160 pi. Okay, then we can reciprocate or transpose x into the negative you can transpose X. Well, actually, what we can do, uh, sorry, this is supposed to be positive, right? 2/3 pi minus half pi minus half pi. Excuse my handwriting. Minus half pi is positive 6 pi, so that's positive right here. Then we can transpose those two. And when we do transpose it, we have x is equal to √8 over e the 6 pi. Okay, like that. And then that's it for the differential equation question. Okay. Right. So that's it there. And it goes there, and then it goes there. Right. Okay. Question 9. It says the lines L and M have the equations. There's two equations relative to the origin or the position vector of the point P is at. Given that L is perpendicular to M and that P lies on L, find the values of the constants A, B, C. All right. So I'm going to draw a sketch for the scenario that we have. So this is just a sketch. It's not accurate. So I'm just going to assume that this is M. And then I'll assume that that's L. So they are perpendicular. What do we know when the two lines are perpendicular? We know that their directions, the scalar product of their directions will be equal to 0. So we will use that vector, right? And then in this case, since I have P is also on the point L. So let's just say P is somewhere there. So remember when in the equation of a line, lambda shows what value. So P, for us to get to point P, a lambda would have to assume a certain value, right? So we're going to use that fact to find the value of lambda. And then when we find the value of lambda, we can find what A and B are, since we have 3J here. Okay, so I'll show you how we are doing that. So the scalar product, so in this case, the direction vector of L is 2. It's C, -2, 4, right? And then the direction vector of M is 2, -3, 1, right? Then the scalar product for those two, that's 2C, 2 multiplied by C, and then -2 multiplied by -3, that's +6, 4 plus times 1, that's +4. We know that it's equal to 0. So we have 2C plus 10 is equal to 0. Then we have C is equal to -5. Okay, so that's our first value. Then we want to use the fact that we want to use the fact that we have point P to find what lambda will be. Remember, R is simply a substitute for x, y, z, right, like that. So what R is simply a substitute for. So we have the point P in this case, which is 4, 7, -2. Okay, is equal to A, 3B, right? In this case, I'll combine them. Plus. Okay, I'll combine it like this, plus, or multiply lambda in. 2, lambda C, and C is -5, so I have -5 lambda, right? Minus 2 lambda plus 4 lambda. Okay, so we can use the second row to find what lambda is, since it's complete. Okay, so we have 7 is equal to 3 minus 2 lambda, right? Therefore, lambda is equal to -2. Right, it's just as simple. Now, now that we have lambda, we can find what A and B are. So from the first column, from the first row, 4 is equal to A minus 5 multiplied by -2. Then this is to give you 4 is equal to A plus 10, right? Take the 10 to the other side. You would get your A is -6. Then we do that with the last row, right? This is just 1, do that with the last row. We have negative 2 is equal to b plus 4 multiplied by lambda. Lambda is negative 2. Then you have negative 2 is equal to b minus 8, right? And then you can take the negative 8 to the other side, then it becomes positive 8. So you have negative 2 plus 8. Then you have your b is 6. Okay. And then after that, you would have completed this question. So that's, you have your a is negative 6. You have your b is positive 6. Then you have your c is negative 5. Okay. And then those are your answers. You have to get all three to get 1 mark. Yeah, it's tough life. But well, that's how things are. All right. So this is it for question 9. I'm zooming out for those who may want to take a screenshot. All right. Okay. Then part B says the perpendicular upon P meets line M at Q. Right. The point R lies on PQ extended with PQ being direct a ratio. PQ is to QR with the ratio of 2:3. Right. Find the position vector of R. Right. So I'll draw again a hypothetical situation here that we have. Okay. So all right. Just checking the space that I have. It's very limited. All right. So this is the scenario that we have. Again, this sketch is not accurate. It's just a random sketch. So we have a line. We have this line M, and then we have P, right, somewhere there. Then we know that it is a line, and then we know that there is a 90-degree angle between P since they are perpendicular. Since it says, remember the question says that they're perpendicular from P. So this is where point P is, and then R is somewhere here. Right? And then the question is telling us that PQ, Q is here. Remember they meet at Q. The perpendicular from line meet at Q. So point Q is right there. Right? This is where point Q is. So the question is still telling us that PQ, the ratio for PQ and QR is 3:2. Right? That is what it is telling us. So what we want to do, we want to find what point Q is, and then find the direction PQ, and then we can use the ratios to find what R is, to find what what PR or what QR is, and then when we have those two, we can just use the formula of this line, of the line which connects P, Q, and R, and then we use that formula to find what the position vector of R. Right. If that doesn't make sense, it will make sense as I work out the question. But what I want to do first is to move this to the side. Okay. I'll move that to the side so that I have my working space back. Okay. So we have our points. We have M, right? M is 1, 2, 3. Plus mu 1, 2, negative 3, and also part B is independent from part A, because that might confuse some people. Okay. Okay. And point Q, we know that at point Q, it would be 1, 2, 3 plus 2 mu minus 3 mu plus mu. It's only that mu will assume a certain value, right? So that for a point Q, right? We want to find what that mu value will be. And then, so we also know that point P is equal to 4, 7, and negative 2, right? We know that the direction PQ, right? The dot product of the direction of PQ and the dot product of the direction of L would be equal to 0, since they are perpendicular here. As you can see on the graph, they are perpendicular, right? And we know that the scalar product or the dot product would be equal to 0. So we will use that fact to find what the value of mu would be. Right? We want to find the value of mu when this condition is fulfilled. All right, so we have our PQ. First, we need to find PQ. Then we'll subtract that 4, 7, -2 from that. When you do the subtraction, we have 4 minus 1, which is 3, 7 minus 2, 5. And then we have -2. Right, P is what? P is -2. This is -2, yeah? This is supposed to be 7. Okay, -2 minus 5, which is -5. So we have 3, 5, and -5. Okay, and then this is minus, so it's -2u plus 3u minus u, because we subtracted p from q. I mean, subtracted q from p, right? Okay. Then once we have that pq, we want to find the dot product. So we have 3 minus 2u, 5 minus 3u, -5 minus u, dot product with the direction m. In this case, the direction for m would be 2, -3, 1. So then we have, you multiply that, we have 6, 2 multiplied by 3, 6, 2 multiplied by -2, which is plus 4, right? And then we have -3 multiplied by 5, -15, -3 multiplied by -3 mu, that's plus 9 mu, right? Then we have 1 multiplied by -5, that's -5, 1 multiplied by negative mu, that's negative mu. Then when we simplify that, we have -14 minus 14 mu is equal to 0, right? Because remember, we say the dot product is equal to 0. So thus we have mu is equal to -1. Okay, so what we've essentially found out is that for this condition to be fulfilled, for this condition to be satisfied, mu will have to assume the value of -1. So we can find what q is, right? Okay, so q, in this case, we want PQ actually, since we just wanted the direction. So the direction PQ, we're going to substitute mu in this direction PQ. All right, so we have direction PQ as 3 okay. So this direction here, which I've been using this entire time, this is actually QP, not PQ. It's the other way around. Which that's fine. So I just correct that. That becomes QP. Right. This is QP. So this was QP in that direction. We want PQ so that we'll compare it with PR going down. Okay, so what you can just do, you just multiply by the negative reciprocal. That's all. Just reciprocate with the negative sign. You just multiply with the negative sign. Okay, to get QP, to get PQ in this case. All right, so I'll find what PQ is. So it's like this. So PQ is equal to negative multiplied by QP. All right, that's what I'm going to do here. So I have 3 minus 2 minus 1, then 5 plus 3, -1, -5 minus -1. Overfit bracket, we have 5, then we have 2 and -4. Yeah, right. We want to multiply that by -1. When you do that, we have -5 plus 2. We have -5, -2, and then +4. And then this is now PQ. Going down this direction here, going down. This is PQ. Okay. All right. So now that we've PQ, I'm going to use the fact that using the ratios that I've been given, or use this ratio, this fact that PQ So PQ, right, is equal to 2/5 of PR, right? As you can see, if you go back to the diagram, this is P, this is R, right? So it's 3 plus 2, which is just 5. The whole factor is just 5. And we know that PQ, this is Q, PQ, in this case, PQ, right? And this whole thing will be PR, right? So PQ would be equal to 2/5 of PR. Okay, that is the factor we're going to use to find what PR is. All right. Okay, so PR, in this case, with the direction vector for PR, we have this becomes PR is equal to 5/2 multiplied by PQ. Okay, find the direction. To find the direction for PQ, I mean for PR, the whole line. We want the whole line because it says point R lies on PQ extended. Right, so this is PQ, then we extend it, then we have R, right? Okay, so we'll now see PR is equal to 5/2 multiplied by PQ. PQ we already have it, which is -5, -2, and 4. Okay, all right. So that's the direction for PR, right? So now to find R itself, we're starting from P. So now OR is equal to OP plus the direction PR. Okay, that is what OR will be. All right. Okay. So this is equal to -25/2, -10/2. That's -25/2, -10/2, and then +20/2. That is what PR is equal to. That's OR, direction OR will be equal to R. In this case, remember this, we just did the equation of a line anyways, right? You could also have written OR is equal to OP, the starting point, right? This one. And then remember we would have some variable plus, let's say, some variable beta. And then the direction for the line would be PQ, right? But we know that beta in this case is just 5/2. Okay. And then this whole thing would be PR, direction PR. Okay. I hope that makes sense. If that doesn't make sense, comment in the comment section if that doesn't make sense. So then it becomes P OP now is 4, 7, -2. Remember, OP is P, the same as P, yeah. This one, this is OP, this is OQ, this is OR. All right. So remember, it's a line and the equation of the line. So we could use PQ as the direction, and then the factor to get to R would be 5/2, right? To get to R. And then so we would add from P. So we'd say P plus the factor 5/2 multiplied by the direction PQ. Then we would get to OR. Okay, that makes sense. All right, so that's what we are doing here. Add that to PR, right? Which is that right there, which is this one. That's what PR is. So I have -25/2, -10/2, and then 20/2. Okay, we do that addition, we have -17/2, then 2/8. All right, and then you want to write it in the position vector form. Right? You have to write the final answer as negative 17 over 2I plus 2J plus 8K. If you don't write it in this form, you're not going to get the last mark. Okay? And then when we've done that, would have completed that question. Okay, if you want to take a screenshot, I'll zoom out for you. There you go. Take a screenshot right there. Okay. Question 10. Let f of x. By the way, if question 9 doesn't make sense, question 9b doesn't make sense, you can comment, and then I'll try break it down for you even further. All right. Let f of x be equal to 21, be equal to this fraction. Express f of x in partial fractions. Okay, so partial fractions again for the second time in this question. All right, so you want to assume that the decomposed fraction looks something like that. A over. First things that you need to check, is it a proper fraction? As you can see, it's gonna be a proper fraction because the highest polynomial in the numerator is x squared, and then the highest polynomial in the denominator will be x cubed. So it's fine. It's a proper fraction. It's proper. All right. So now the decomposition would probably look something like that: a over 1 plus 2x plus b over 3 minus x plus c over 3 minus x. Sweet. All right. Okay. And then that should be equal to f of x. Okay. I have one page. Okay, I just have one page. So I would say a, then you divide this, you divide 1 plus x, you divide the denominator with over 1 plus x. So it will be divided by 1 plus x. Right. That then the solution is what you put, is the multiplication with a, the multiplicand of a. So it'll be 3 minus x squared minus x squared. Right, then plus b. Do the same thing here. Minus 2x. Remember, if we were to combine that, that is the same procedure that you take to get to f of x. So essentially just repeating that same procedure, but with the unknown value of b, a, and c. All right. 3 minus x plus c 1 plus 2x. And all of that is equals to f of x. Okay, in this case, just the numerator of f of x. So numerator of f of x. Okay. So now you can go ahead and say let x assume a value of perhaps 3. And then when it assumes a value of 3, this becomes 0. This becomes 0. 3 minus 3 is 0. 3 minus 3 is 0. And you can solve for c. 3 multiplied by 2, that's 6 plus 1, 7. Then you have 7c is equal to, then you want to plug in that value in this numerator here. When you do that, you have negative 21. You get negative 21. Therefore, you have your c is equal to negative 3. Then you want to let x assume a value of negative half. When you do that, this becomes here negative 1. So this term goes to 0. Then also this term goes to 0. Right. Then now you're left with the a. Then you would have 3 minus half. That will be 2.5 squared. That's 49 over 4. All right. A would be equal to 49 over 2 here. You can cancel out those 2. Then you would have your a is 2. Okay. Then for b, we're going to do a comparison of coefficients for the x squared term, right? So if we were to expand this term here, we would have at some point when we're finished, we would have ax squared, right? Then plus some other variables. And then also, if we were to expand that day, we would have 2x multiplied by negative x multiplied by b, right? So we would have the term, the coefficient with the x squared term would be negative 2b, and then with the x squared term, then we want to equate that to the x squared term in the numerator there, which is negative 2x squared. That's what we can do a comparison of coefficients when we have a minus 2b is equal to negative 2. All right. And then we also know that a is equal to 2. We can substitute for a. And we have 2 minus 2b is equal to negative 2. Take that the other side, we have negative 2b is equal to negative 4 divided by negative 2. That's b is equal to 2 as well. All right. So now we can write our solution. A is equal to 2. B is equal to 2. C is equal to negative 3. Okay, there you go. All right. You can take a screenshot if you want. All right, that should be pretty straightforward and clear. Now, you want to, hence, it says hence, so which means you're using the answer to the previous question. You know what, guys? It's probably best to check these values for ABC, because if they are wrong, you're going to carry them forward. I doubt you'd get any marks. You probably get maybe 1 out of 5. In most cases, you get 0. So to check, I'm gonna check for you. So I'll check whether what we did is correct. So before me checking, I want to show you how you check whether these values are correct. So what you simply need to do is to use this equation here to check. You want to use this equation here to check. Okay. All right. When you're substituting the value for A, B, and C, when you're substituting those values, you're supposed to get the numerator. Okay. All right. So let me do it very quickly. So you would have 2. Sorry. You would have 2 bracket 3 minus x squared plus 2 3 minus x bracket 1 plus 2x bracket minus 3 bracket 1 plus 2 x. When you expand that, you have 2 bracket 9 minus 6x plus x squared bracket plus 2 3 plus 5x plus 2x, minus 2x squared bracket minus 3 minus 6x, and then you simplify, you have 18 minus 12x plus 2x squared plus 6 plus 10x minus 4x squared minus 3 minus 6x. You simplify that, you'll see that you have 2x squared plus 21 minus 8x, which is equal to the numerator of f of x, right? Thus, your values for a, b, c are correct. You can see you have negative 21, negative 8x, and negative 2x squared. And that's what you have here. All right. So now you can use your values and work out b. Okay. And then for this part, I want to show you the best way to attempt this question so that you don't make mistakes. Because most people know how to do the expansion, but then they make silly mistakes and then they end up losing marks. So first things first, you write your f of x in partial fractions. Okay. Sorry. All right. Plus 2 over 3 minus x plus minus 3 over 3 minus x bracket squared. What you want to do is you want to do the expansion in parts. So divide it in parts, and you want to do the expansion in parts. Okay. All right. So first part 1. Okay. you want it to be 2 bracket 1 plus 2x to the negative 1. Then you have n is equal to negative 1 and x. I will also write x bar to differentiate it from the x that is in the in the function. Then the formula that you want to use for doing the expansion, it's 1 plus n x. You see, this is now the x in the x bar, which is in the formula. So this is the x bar that you substitute with the x function that is in the f of x function. All right, then you see 1 plus nx plus, and then it says expand up to the term including x squared. So for that part of the formula, it's just be x bar squared, like that, and then it keeps going. Or we just want it up to the x term. So now, okay, I think I've wasted a lot of space so far. So what I want to do, I'm gonna reduce its size so that I have slightly more space. Okay. So now we can do the substitution. And also, you want to write these in the form. I almost forgot. You want to write 1, 2, 3 in the form 1 plus n for the formula, so that's 1 plus n, 1 plus a, 1 plus x, right, to the n, like that. That's the first thing that you want to do. So if this 1 is not a 1, what you want to do is you want to factor out whatever integer that you have so that you're left with 1. All right. So now you can carry out 1. That would become, once you substitute that in the formula, then you would have 1 negative 1 plus negative 1 multiplied by bracket 2x bracket plus negative 1 bracket negative 2 over 2 factorial multiplied by 2x squared, right? And then all of that, you want to multiply all of that by the 2 that we have outside this 2 here. Okay, so your final solution should be, when you simplify that, 4x 2 minus 4x plus 8x squared. Okay, and then that should be your 1. All right, and then for 2, okay, it becomes 2 3 minus x to the power of negative 1. We're taking that the denominator and writing it to the power of negative 1. Then you want to factor out the 3, because remember, you want to put this into this form. All right, okay, so it becomes 2 multiplied by 3 to the negative 1, because remember the 3 was inside the bracket and it shares to the power of negative 1. Bracket 1 minus x divided by the 3 that we just factored out at the negative 1. Okay, thus we have our n is equal to negative 1 into our x bar is equal to negative x over 3. All right, okay, and then now this becomes 3 over 2, 2 over 3, sorry, bracket, but we use the formula 1 n, then our n is negative 1 plus n, which is 1, multiplied by the x bar, in this case which is x over 3, plus the n, right, which is in the formula, which is negative 1 in this case, multiplied by n minus 1, which becomes negative 1 minus negative 1 minus 1, which is negative 2. All of that over 2 factorial multiplied by negative x over 3 bracket squared. We simplify that, it becomes 2 over 3 multiplied by 1 plus x over 3 plus x squared over 9 Okay, and then the final answer for the second part will be 2 plus 2 over 9x plus 2 over 27 x squared. So that's 2 right there. Okay, and then for the third part, we're going to do the same procedure again. Part 3, do the same procedure, and then we have negative 3 outside, 3 minus x, negative 2, and then it becomes negative 3. You factor out the 3 to the negative 2, right, multiplied by 1 minus x over 3 the negative 2. Thus we have our n is negative 2, and we have our x bar is negative x over 3. Then we carry out the expansion. Outside we have negative third, because we said negative 3 multiplied by this negative 3 multiplied by t to the negative 2 will be equal to 3 over 3 squared, which is essentially 3 multiplied by 3. Then we divide that, so we'll be left with the third, negative third. Okay, that's what we did to get this negative third. Then bracket all right, so you simplify that becomes 1 plus 2 over 3 x plus x squared over 3, then square bracket. Okay, when you simplify that, it becomes negative 1 over 3 minus 2 over 3 minus 2x over 9 minus x squared over 9. Okay, then that's part 3. Then what you want to do is you want to add them. 2 plus 3. When you do the addition, you would have 7 over 3x minus 4x plus 215 over 27 x squared. Remember, you're just plugging this in the calculator. So what you're saying, in your calculator, you're saying 2 plus 3 over 2 minus 1 over 3. And then you get 7 over 3. All right. Then you're saying negative 4x plus positive 2 over 9 minus 2 over 9. So these two cancel out. So you're just left with the negative 4x, which is in this part. Then you see 8 in the calculator plus 2 over 27 minus 1 over 9. Then you have 215 over 27. So when you've done that, you'll be guaranteed to get your full marks. But just try to do the expansion one by one, and then that way you won't make mistakes. All right. Okay. So now question 11, which says the complex number c is defined by z is equal to 5a minus 2i plus over 3 plus ai, where a is an integer. It is given that the argument of z is equal to that. Find the value of a, hence express z in the form 6 plus iy, where x and y are real. All right. So the first thing that you want to do is you want to rationalize z, so that you write it in the form z is equals to some x plus yi. Okay. Over 1. That's what you want to do first thing. Okay. Because what you have is, since the argument of z is a negative quarter, this is what you have. The value of z, something like this on an Argand diagram. Looks something like this is imaginary z, and then this is real z. So what you have is somewhere there. This is where z would be, and this is a negative quarter pi. Okay. So you want to first find the value of y and z. Then when you have those two, you know that the imaginary part is going to be a negative here. Whatever value it will be, it is going to be negative, and then the real part is going to be positive, right? It's going to be positive. Okay. And then we can reverse that argument of z. Then we can find the values for a, the value for a. So the first thing that we want to do is to rationalize the denominator. So z is equal to 5a minus 2i over 3 plus ai multiplied by the conjugate of the denominator. Okay, when we do that, we have 15i. It's 5a multiplied by 3 is 15i. And we go outside 5a multiplied by negative ai. We have negative 5 squared, negative 5a squared I minus 6i, and then plus 2ai squared, right? And then we're going to divide all of that over 9 minus 3ai plus 3i minus a squared I. These two are going to cancel each other out, right? So we will now have the I squared is negative 1, right? Thus we have 15, we have 15a minus 2a. That will give us 13a minus, we collect like terms for the I. We're going to say minus, so we factor out the minus from 5a squared I and 6a I. When we do that in combined like terms, we have 6 plus 5a squared I. All of it is over 9 plus a squared I, because remember this is also I squared and it's negative 1. Negative plus times negative gives us positive. So then we can now split it, the form, to change it to the form, to convert to the form, to this form here. We have a coefficient x and a coefficient yi. All right. We do that, we have 13. In this case, we have z is equal to 13a over 9 plus a squared, right? And then we want to add, and then we take the negative back. So we have negative 6 minus 5 a squared, right? Bracket I over the denominator, which is now just a constant. All right. Okay. So now it's in the form x, coefficient x plus coefficient yi. Okay. And then we also know that the argument of z, right, is equal to tan inverse of y x, right? Therefore, z is equal to tan negative a quarter pi, right? Which is just negative 1. Okay. So now we can see x over y, because remember to get the quarter would say y over x. So now we can see y, we have negative 6 plus 5a squared y so over 9 plus 9 plus a squared, and then all of that, because this is now just representing y over x. All right, 13a over 9 plus a squared, all of that is equal to negative 1. All right. Why does this work? Because remember, to get the quarter, we said tan inverse. To get argument of z, we said tan inverse of y over x, right, was equal to a negative quarter pi, right? But y over, to get that negative quarter pi, y over x was equal to negative 1. That's why we are equating now y over x is equal to -1. All right. So now we can simplify that. We can cancel out these two are common, cancel out the negative right there, and then we can take the a to the other side. Right. So now we have 6 plus 5 a squared is equal to 13a. Right. And then we can take the 13a to the side, then we have 5a squared minus 13a plus 6 is equal to 0. Okay, then we can use the quadratic formula to find the values for a. Okay, so we have a is equal to negative 13 plus or minus square root of negative 13 squared minus 4 multiplied by 5 multiplied by 6, all of it over 2 multiplied by 5. Then we have a is equal to 13 plus or minus root 49, all that over 10. Then we have our values for a1 is 2 and a2 is 3 over 5. If we simplify those two in the calculator, right? Two values for a, right? But we know that a is an integer because the question told us, right here. It says that where a is an integer, okay? So every piece of information that you get in a question would be useful. So in this case, we know that but a is an element of the integers, right? So this cannot be a. Therefore, our a is 2. Okay. But remember, that's not the question. The question didn't ask for the value of a. It says find the value of a and then express z in the form x plus iy. So we're going to use this here. We use this part to find z. Okay. That's our z would be z is equal to 18 multiplied by 2 over 9 plus a squared, which was 2 squared, plus -6 minus 5 multiplied by the a squared, which is now 2 squared, over 9 plus 2 squared I. Therefore, z is equal to 2 minus 2i. Okay. That is what the value of z would be in this case. And then we also know that a is equal to 2. Okay. Delete that. So a is equal to 2. All right. So that's it for this question here for 11a. And if you want to take a screenshot, there you go. And the other one, there you go. All right. The last part of this paper. Okay, it says that express z cubed in the form re by theta, where r is greater than 0 and theta is in that given domain. So what you want to do here, you have your z cubed, which is equal to 2 minus 2i cubed. Okay. If you don't have a calculator, you can use the binomial expansion formula. And you can expand this using that binomial expansion formula. So that formula states that because it's a binomial expansion of a plus b to the n. So it would be a to the n plus n, choose 1, multiplied by a to the n minus 1, b to the 1 plus n, choose 2, multiplied by a n minus 2, b2 plus n, choose 3, right, multiplied by a to the n minus 3 and b3. Okay, so that's what we can use to expand that if you don't have a calculator, but you can just put in the calculator. So once you do use that formula, you would have 2 to the 3 plus 3 choose 1 multiplied by 2 to the 2 multiplied by -2i plus 3, choose 2, multiplied by 2, multiplied by negative 2i squared plus 3, choose 3, which is just 1, right? Multiplied by 2 to the 0, which is just 1, multiplied by negative 2i to the 3. Negative 2i to the 3. Okay. Right. Then we have 8 minus 24i plus 24i squared is equal to negative 1 plus 8i. Then we have negative 16 minus 16i is equal to z to the 3. Okay. All right. So now that we have that, in this case, I'm just going to use the additional page. Find your r, since your z to the 3 is equal to negative 16 minus 16i, right? Find r. R is the modulus, right, of z. So the modulus of z, which will be square root negative 16 squared plus negative 16 squared. We have r is equal to 16 root 2. Putting that in the calculator, right? Then you have for theta, it's basically the angle, right? You can draw your Argand diagrams to the side. Negative 16, negative 16, 16, negative 16i. That's where z to the 3 is, right? But remember, it says that it wants a value from pi to pi, from negative pi to pi. So going back, this is negative pi, and then in the anti-clockwise direction, that's positive pi. Okay, so if you put the argument of z to the 3, it will be tan inverse of negative 16 over negative 16, right? And we would get a quarter pi. But remember, the quarter pi is here, right? The quarter pi is not this one, right? You're getting this quarter pi here. Okay, so, but that's not the answer, but that's not the argument, right? Remember, the argument is the angle starting from the positive axis. So you have to start from here, and you either go in that direction, which is positive, or you go in that direction, which is negative. That is what the definition for an argument really means. Okay, so in this case, if we go in the positive direction, it will be greater than pi, as you can see. But our range for theta, we know that it's supposed to be within negative pi and pi. But if we go in the negative direction, this one, it will be less than negative pi. We can do that. So we would say, to find this angle here, would say pi minus a quarter pi. I mean minus pi plus pi, right? Then we'll get negative 3 over 4 pi. Okay, thus theta is equal to negative 3 over 4 pi. All right, thus we can now write our final solution, which is equal to 16 over root 2 e to the negative 3 over 4 pi. Okay, if you go to the end of this paper, please consider subscribing, guys. It really helped me to continue making these papers. All right, peace out. Thanks.